today we're going to be talking about arithmetic sequences. The expression formed by adding the terms of an arithmetic sequence is called an arithmetic series. The sum of the first n terms of an arithmetic series is denoted by S sub n. So we have two different rules that we're going to be working with arithmetic series. The first one is S sub n equals n multiplied by the entire quantity a sub 1, meaning the first term, plus a sub n, meaning the last term. N here is talking about the number of terms that we're looking at, and then you would divide this by 2. We use this rule when they give me the first and the last terms of this sequence. If they don't, and they tell you that D value, that common difference, then you're going to have to use this rule, which is S sub n equals n divided by 2 multiplied by the entire quantity 2 times the first term plus n minus 1 multiplied by D. So we're going to try some examples where we apply what I just said. So the first one, it says, what is the sum of the arithmetic series? So if I look here, they tell me I'm starting at 1 and I'm looking at 20 terms, and they tell me the rule. They don't tell me anything about the D value here. So I'm going to start by finding the first term. So a sub 1 is going to be 3 plus 5 times 1, which will give me 8. And I'm also going to find the last term, which is a sub 20. Which is going to be 3 plus 5 times 20, which will give me 103. So now I can use that first rule we talked about, because they give me the first or the last term. I'm able to find the first and the last term. So here, S sub 20 is going to be equal to 20 multiplied by 8 plus 103 divided by 2. So when you do that all out, you will get that S sub 20 equals 1,110. So if I were to add all of the 20 terms in this sequence, I would get 1,120. Now you do not want to list out all of the terms and then add them. You actually want to use these rules and find the value of the arithmetic series. So let's look at another example. Same type of idea. I'm looking, starting at 1, and I have 28 terms. So once again, I can find the first. I can find a sub 1, which is going to be negative 2 plus 4 times 1, which will give me 2. And I can find a sub 28, which would be my last term here. This is going to be negative 2 plus 4 times 28, which would equal 110. Then, once from here, I can do the same thing as before. I can find the sum of all 28 terms. So this is going to be 28 multiplied by 2 plus 110 divided by 2. So you get the sum is equal to 1,568. I'm going to let you try that next example on your own. You should get that the sum of the 12 terms is 570. Practice that one. All right, the last one I have for you is that you are making a house of cards like the one below. I'm sure you've all done this before. Write a rule for the number of cards in the nth row if the top row is 1. So we're saying that the top row is 1. So this top row here, we're going to let we're going to let this first row here be our first term. If you look, there's 3 cards here. And then in my second row, which is representing my second term, there's 6. And then if I look further on, there's 9. So here I'm seeing that my D value is 3. I'm multiplying by 3 to my n value. So I can write a rule, a sub n equals, my first term is 3 plus n minus 1 times 3. Clean that up a little. So I get a sub n equals 3n. They also ask me in B, what is the total number of cards if the house of cards has 14 rows? Well, I know, now I'm looking, I know my first term is 3. And now I can find my a sub 14. 14 rows, 3 times 14 is 42. And I can use my rule to find the sum of all 14 rows. So this is going to be s sub 14 equals 14 multiplied by 3 plus 42 divided by 2. So s sub 14 equals 315. So if I had 14 rows of these cards, you would need 315 cards to complete this. I hope you enjoyed this lesson, and we look forward to seeing you in class tomorrow.